Mathematics, Pure Mathematics, Paper 1, June 2023. And then 9 MAO. So that's the advanced level paper. Welcome to Anago. Question number 1. I'll go through these questions, and any of the questions that you think you want to have a go at it first, try it first, pause it, try it, and then you come back and check your answers. Question 1, find the integral of that expression, writing each term in its simplest form. Before you integrate, you have to rearrange or rearrange the expression such that you can integrate them. You notice there's a divide by 3 underneath. So the first thing, we have to remove the bracket. X to the half times 2x, x to the power half times minus 5. Now, what we need to do now, the 3 underneath is divided by 3, which is like 1 over 3. So you take it out of the bracket, out of the integral sign. And then x to the half times x to the 1. 1 plus a half is 1.5, which is 3 over 2. So 2x to the 3 over 2 minus 5x to the half. Now you can integrate. Integrate this first one in circle. After that, you integrate the next one. Integration, you do 2 things. Add 1 to the power and divide by the new power. Don't forget that is the reverse of differentiation. Add 1 to the power and divide by the new power. Very important. So when we add 1 to the power is 3 over 2. 3 over 2 plus 1, it gives you 5 over 2. And then we divide by the 5 over 2. Half plus 1, it gives you 3 over 2. And you divide by 3 over 2. Half plus 1 is 1.5. 1.5 is 3 over 2. So add 1 to the power, divide by the new power. All the exam papers I've marked over the years, there's integration in paper 1 and in paper 2. And pure maths is 200 marks out of 300 marks in your exam. So very important to get this integration. Now you simplify. You get your calculator. 2 divided by 5 over 2, it gives you 4 over 5. 5 divided by 3 over 2, it gives you 10 over 3. Now you multiply by the 1 over 3 outside. 1 over 3 times 4 over 5 gives you 4 over 15. And then 1 over 3 times 10 over 3, it gives you. And then don't forget to add the constant of integration. And that's it for question 1. Congratulations if you got that correct. Question number 2 is for 6 marks. So roughly 6 minutes to do it. So where a is a constant, given that x minus a is a factor, show that, and then hence. There's a hence and a show that. Okay, let's jump in and do that. Because x minus a is a factor, so we will use x equals to a and sub it in. So x equals to a, we'll replace the x with a. You can see a point in there. Wherever you see x, you replace it for a, sub it in for a. So you get 4a cubed minus plus 5a squared, and so on. Now you want to collect like terms. Minus 10a plus 4a. Put down your calculator. Minus 10 plus 4 will give you minus 6. 4a cubed plus 5a squared minus 6a equal to 0. Now you look at the answer because you want to get to that answer. You notice it is 4 in there and 5. So you want to remove the a out of, factorize a out of the bracket, and then you're left with the answer there. 2 marks. Part B says hence. Find the value of hence means use your answer from part A. So we want to solve that equation. So either the a at the back there is equals to 0, which gives us one answer, or this quadratic is equals to 0. Now you want to solve this quadratic, use your calculator. A is 4, B is plus 5, C is minus 6. You get 3 over 4 and minus 2. So we have a negative answer there, and A is 3 over 4. So what you want to do now is, the next step is you want to use 3/4, the positive answer. So when you put a to be 3/4 times 4, you get 3. So f of x is that expression that's equals to 3. You make it equals to 3. You want to solve it now. You can go into your calculator that will solve this equation for you. But you want to show you're working in an exam. So you start by factorizing x out. So x is equals to 0. And then you use your calculator to do that quadratics, or you can write the formula and put it in and simplify it to get those answers. So that's a picture which I put in the calculator. And you notice I put the ax cubed, bx squared, cx plus d equals to 0. I put the whole thing in solving equations in the graphics calculator, and it gives me the 3 answers, 1, 2, 3. And the first one, that's the first one in insert form, and then the next one is 0, the next one is that. So I know the answers, and I can go and show the working out. Question number 3, you can press pause and have a go at it. When you finish, you can come and check your answer. For question number 3, relative to a fixed origin O, the point A has vector and B has that vector. Show that the magnitude of OA is square root of 38. To find the magnitude of a 3-dimensional vector, you would put 5 squared plus 3 squared plus 2 squared, and then square root of that gives you square root of 38. It's like Pythagoras in 3 dimensions. See how I put it in the calculator? It gives me the answer there. Square root of 38. For part B, we need to find OB. We do the same, 2 squared plus 4 squared plus A squared. But we don't know what A is. So we want to show that magnitude of OB is bigger than the magnitude of OA. We know OA is square root of 38 from part A. So we do 2 squared plus 4 squared, it gives you 20. So we want to solve this inequality. Remove the square root from both sides. So 20 plus A squared is greater than 38. You minus 20 from both sides, and you find the square root of 18. In your calculator, it gives you 4.24. And so the integer A has to be greater than 5, because the next integer after 4. Which number comes after 4? The number 5. So that's why we use 5 as the answer. And you can check your answer for OB by putting that 3 root 2. And you will get root 38, which is the same. So for it to be bigger, you will have to use 5. Question number 4. The curve C has that equation y equals to f of x. They've given us f dash of x, which is the same as dy over dx. And they say the angle alpha is small, and there's a stationary point. Use the small angle approximation. When you hear the word small angle approximation, you go straight to the formula book. You look for these 3 formulas. This 1, 2, 3 is what we use for small angle approximation. You see the sign there in the middle, approximate. That sign means approximately equals to. So we know f dash of x equals to 0 if it's a stationary point. So you want to put, which is what you need to remember that. So you put the whole expression equals to 0. But because we are using x as alpha, you replace x with alpha. So you haven't done nothing strange, it's just replacing x with alpha. And then we want to solve that equation using small angle approximation. The 2 alpha stays the same. The plus stays the same. The half stays the same. You want to change cos alpha using the small alpha angle approximation. And change that you're using this expression there. Cos alpha will be 1 minus half alpha squared. You replace it there. Equals to 0. Now everything is alpha, alpha. You want to solve this equation. With the graphics calculator, you can put this and get the answer. But you need to come and show your working out. So the working out, remove the brackets, half times 1, half times minus a half, alpha squared. After that, to remove the denominator, you multiply by 4. You get this quadratic. You solve the quadratic, you get 2 answers for alpha. And you change it to 3 decimal place because they want the answer to 3 decimal place. Have a look at that. 3 decimal place. Don't forget that. You will lose that mark. Change it to that 3 decimal place, and that's it. The point 03 lies on C. Find the equation of the tangent. A tangent is a line. Whenever you see the word tangent, it's a line, and the equation of a line is y equals to mx plus c. So that means we need to find m, we need to find c. Tangent is a line, and you need to find m and find c, and then you can write the equation. So how do we find m? How do we find c? We know dy over dx gives us the gradient function, and they call it f dash. But where does it pass? It passes through 0. So if we put x is 0 in that differential function, cosine of 0 is what? Cosine of 0 is 1. Make sure you get that right. 2 times 0 is 0, so the gradient is a half. So m is a half. After we find m, what do we need to find? We need to find c. To find c, we put y is 3. M, we put y is 3. M is a half. X is 0. And then we rearrange it, we get c to be 3. So your equation, y equals to half x plus 3. Question number 5. For question number 5, we're going to use the trapezium rule. So we want to first of all find h. You get this formula in the formula booklet. You want to find h, the width. So it's 4 minus 3 divided by 5. So that gives you 1 over 5. And why do we divide by 5? There are 5 strips. And how do we know there are 5 strips? That's a problem that students ask. Let's look at the y value. There's 1, 2, 3, 4, 5, 6. Watch this carefully. You can have 1, 2, 3, 4, 5, 6 lines. How many spaces are in the middle? 1, 2, 3, 4, 5. So 6 lines will give you 5 strips. Think of it that way. Now, we need now to identify. The first one is y0 is A, y1 is 16.8, y2, y3, up to y5. We go now into the formula and substitute it in the formula. And we know the total answer for the area is 17.59. So 17.59 is equals to h over 2 is the 1 over 5 is the h, and then they divide by 2, which is 1 over 5 divided by that. And then we go now to, that should be divided by 2. Let me make sure I written it correctly. So 1 over 5 divided by 2, not divided by half. That should be 2 then. So we'll go into the formula now. We put A for the first one. 13.5 is the last one. First, that's the last one. That's the first number. And then 2 times the even ones. And then 2 times the rest. 2 times 16 times the B times the 20 times the 18. So you have to be very careful here with these numbers because you can easily make a mistake and get the wrong answer. When I mark the exams, it's usually mistakes. You have to be very careful here. I use the formula in this form. First number plus the last one plus 2 times the rest. That's how I learn them. And that's the first and that's the last. So substitute them all in that expression there. That 0.2 is the 1/5. And then from there, you see how I simplify them bit by bit. I did 0.2 divided by 2, gives 0.1. I add these two together. And then I add these two and this one, 1, 2, 3 to give me that 55.7. And you carry on doing all the algebra and simplifying until you get to the bottom part. And then you get to this point where 175.9 minus 124.9 gives you 51. And that gives you equals to A plus B. So A plus 2B is equals to 51. And I put a diagram underneath, shows you the 1, 2, 3, 4, 5 strips and the 6 lines. So that's how you do that. For part B, they want us to find the value of A and the value of B. So we put that, add them all together. So A plus 16.8 plus B plus 20 plus 18, add them together. And then that gives you this A plus B equals to 28. But before, because that total there is 97.2, that's where it comes from. Before we had A plus 2B equals to 51. So you got simultaneous equation there to solve. You can do it the way you did for GCSE or use your calculator. You get B is 23 and A is 5. Bear with me. I go straight to my calculator to do simultaneous equations. I put in the numbers 1, 1, 28, 1, 2, 51, and it gives me the two answers, 5 and 23. Question number 6. So for question 6a, square root of x is x to the power half. So the half can come in front using one of the laws of log. So it's half log x to the base 2. But what did they say x to the base 2 is? X to the base 2 is equals to a. So you replace that with a. So the answer is half a. For part B, we have x squared plus 8x. What can you factorize out? You got x can come out is x times x plus 8. We know log x to the base 2 is equals to a. So we write that as a. And then log x plus 8 to the base 2 is b. So that's a plus b. So the trick is to look at the thing you want to change it to so that you know what to do with that. Always look at the answer that you want to change to. Part C is the one where you need to be a little bit careful. We have 8 plus 64 over x. We need to deal with this fraction in the middle. So 8 is like 8 over 1. So we do 8 over 1 plus 64 over x, and you get this expression, 8x plus 64 over x. When you divide, there's a top part and the bottom part. When you divide, what do? You subtract their logs. So you write the top part in log form and the bottom part to subtract it. Now 64 is 8 times 8. So you can factorize 8 out. Now you got log of 8 to the base 2. You don't need to worry about knowing some things. Put that in your calculator. Put that in your calculator, 8 and then 2 there. It gives you the answer. Or you can do it the way I've done it. 8 is 2 cubed and 3 comes in front, so you get 3. And then because you are multiplying, you separate them and add them. So that one is b, and minus log x to the base 2 is a. So it's 3 plus b minus a. Question number 7. For question 7a, it says state the range. Very important to understand this. If you have your y-axis, put it there in black, and the x-axis in pink. What goes in the x-axis is the domain, and what goes in the y-axis is the range. So the question says state the range of f. What goes in the x-axis? Every real number, and x has to be bigger than 2. If it's smaller than 2, it has to be bigger than 2. If it's smaller than 2, 1 minus 2 would be minus 1. And you cannot find square root of minus 1 unless you use complex numbers. So x has to be bigger than 2. So x can be 3, 4, 5 upwards. All the numbers bigger than 2. So if you put 3, if you take 3, the first one, put it in, the answer will give you 4. 3 minus 2 is 1. Square root of 1 is 1. 3 plus 1 is 4. Or if you use the minus part of the square root, it's 3 minus 1, it gives you 2. So what you want to do, the range will be f of x is greater than or equals to 3. Find the f inverse. Yes, most of the time when we do inverse, students don't know why we do them or what it means. If I put a y-axis there and I put an x-axis and I put this line in the middle, what color can I use? I use blue. This line in the middle is y is equals to x. Whenever you have a reflection in that line, where that line is like the mirror, that's what it means by finding an inverse. So if you have a line underneath here, let's put that, and then when you do the reflection of that curve, that on that y equals to x, you're finding the inverse. So let's just go ahead and do the inverse because they don't ask you that in exams. To do this, show the explanation. Replace the f of x with y. Replace f of x with y. It makes it easier to write. And then you want to make the x the subject. Start by removing the 3 minus 3. And then remove the square root. The square, you change it to square root. Sorry, the square root, change it to square. And then the minus 2, it goes to plus 2. And that's your answer. And then you replace the x bar with f inverse. Now for this one, part C, find g f of x. So what we want, we got 6 in front there. We go to f and put 6. This is the function for f. We put 6 for x there and work out the answer. When you put 6, your first answer will be 5 when you use the plus, and your second answer will minus 1. Sorry, 1. Now you got 2 answers, 5 and 1. You take that answer, you put it in G now. You go to G and put that 5. So you take the 5, it goes to where x is in G. So that's 15 over 5 minus 3, 7.5. If you use the 1, 15 over 1 minus 5 is minus 7.5. It says find the exact value. Exact in any exam question means don't leave it in decimals. Leave it as a fraction or as a surd, like square root of 2. Don't leave it as decimals. So we have an equation to solve. F of a squared plus 2, that means wherever you see x, replace it with a squared plus 2. So we have x in there, we replace it with a squared plus 2. And we know g of a, we replace x with a. So now we got the, and then we simplify. 2 minus 2 is 0. Square root of a squared would be a. So we have this equation to solve. You do it by cross multiply. This is like 3 plus a over 1. You cross multiply. So 15 times 1. And then from there, you expand the double brackets and cross out the like terms. And you end up with a squared is 15 plus 9. A is square root of 24. And the answer will be 2 root 6 or minus 2 root 6. And for those who have the graphics calculator, you go to a function they call solve n. Solve n. You put that 3 plus x, because it was 3 plus a and then a minus 3, but we don't have a in the calculator, we use x. 3 plus x equals to 15 over x. And then it would give you the two answers. So you will know what the answer is, and then you can go and show your working out. Question number 8. You can press pause and have a go at it, and then you come back to check your answer. So for number 8, it says show that OC is 12. OC is that distance I put there in pink. How do we find that OC? We're going to use only this part there is like a fan, some kind of a fan, a Chinese fan. I bought fans from China that looks like that shape. So we use the formula L is arrow times the arc. The L stands for the arc. It's arrow times theta, and that's the arc there. Arrow times theta in radians. That C means the angle is in radians, not degrees. Very important. Make radius the subject is L divided by theta, and L is 27.6 divided by 2.3, and it gets you 12 meters. For part B, we want to show that the angle AOB. AOB is the shaded angle there. So what we want to do is, you think of a straight line. AOB is that shaded angle plus GOF. GOF is this angle on this other side there. So AOB and GOF plus the one in the middle, all of them are on a straight line. And this is the straight line in blue there. Look at that blue line there. There's 1, 2, 3 angles there. So we call them X and X, they are the same. So 2x plus the one in the middle, 2.3 equals to pi radian. So pi minus 2.3 divided by 2, it gives you the angle, and you change it to 3 decimal place, 0.421. Part C, find the total area of the stage. The area, how big that stage is. So we got BC, D, E, F. So we want to find BC plus CDE plus EF. So we know BC and EF are the same. BC and EF are the same. We call them X and X, so that gives us 2X. And we know that one is 27.6, and they say the total is 35 meters. Solve it, you get X to be 3.7. So the area of OAB is half AB sine C, which is the same as the area of OGF. So half times 7.5 times 12 times sine of that angle. Make sure your calculator is in radians. You get area to be 18.390. So you want to find the total area of the two triangles. You times by 2. That gives you the area of 2 triangles. And then the area of the sector, half arrow squared theta in radians. The radius that you did in part A is 12. The angle is 2.3. You got that area. So the total area of the stage, the area for those two triangles, the area for that sector, and it gets 202.38, which is 202 meters squared. Question number 9. They're giving you the first 3 terms. In geometric sequences, the second term divided by the first, second divided by the first is the same as the third divided by the second. So the second divided by the first is the same as the third divided by the second, and that's equal to the common ratio. Put that together, and then you cross multiply, and then you want to solve this equation. Expand the double brackets on both sides, and be very careful with the minus signs. And then you put everything to one side. And then from there now, you can solve this with your calculator. You don't have to do this simplification by 2, divide by 2, to get this there. So we divide by 2 to show the answer there, which they want us to show. But when you want to solve it, you just solve it in your calculator and get the answer. So we got the equation there, we need to solve it. You put that in the calculator, you get 2 over 3 and 20. And that's what I've done there. Look at the picture there for putting in the calculator. You use the ax squared plus bx plus c. And you get 20 and 2 over 3. Now, if we use 20 times 3 plus 4, 12 minus 3 times 20, and 20 plus 16. That gives us 64 minus 48 and 36. Let's see if the ratio is less than 1. So the second one minus the first, second term divided by the first. So minus 48 divided by 64. It should be the same as the third term divided by the second. 36 divided by minus 48. The answer is minus 3 over 4. And if you look between minus 1 and 1, minus 3 over 4 is inside. So minus 3 over 4 is between minus 1 and 1. If I draw it on a number line, you have minus 1 at this end. You have 1 over there. And minus 3 over 4 is there. So k equals to 20 is the correct one, because you need to have the absolute value of r less than 1. Or think of it this way. The common ratio has to be between minus 1 and 1. If you try the next number, the next value for k, 2 over 3, replace k with 2 over 3, 2 over 3, 2 over 3. You work it out, you get these 3 answers. When you do the second number divided by the first, 10 divided by 6, you get 5 over 3, which is bigger than 1. The third number divided by the second, you get 5 over 3, which is bigger than 1. So that would not work. So we want to find the sum to infinity. This symbol there, it stands for infinity. And it only works when that common ratio is between minus 1 and 1. So the first number is 64, and that common ratio is minus 3 over 4. Get this formula from the formula book. Put 64 for A, and put minus 3 over 4. And put that in the calculator. Be careful with these 2 minus there. Students always forget that. It be plus. And then you got 36 and 4 over 7. Question number 10. Question 10 wants us to find the coordinates of the center. So the coordinates will be x and y, like that, and then the radius of the center. So we need to do what they call complete the square. So what I can do is I put the ones with x together. I put the ones with y together. And I think of half of 6 is 3. So we want to make this x plus 3k, x plus 3k. When you expand that, it gives you that expression. So we got the x squared, we got the 6kx, but we got the extra. This 9k squared is extra. We do the same. Half of 2 is 1. So we do y minus k times y minus k. That gives us y squared minus 2ky, and then plus this k squared. This k squared is extra. So what do we do with this, the ones that I call the extra? I'll show you in the next slide. You minus the extra one, 9k squared, and you minus the k squared. So minus 9 minus 9k squared minus k squared is minus 10k squared. And you take it to the right, it becomes 10k squared. The plus 7 goes to the right, it becomes minus 7. So it becomes 10k squared minus 7. So your center is the opposite, it's plus 3 there, make sure the center will be minus now. So it's minus 3k, and it's minus k, there it will be plus k. So that's the center. And the radius is square root of that, because that is equals to r squared. So the radius will be the square root. Another way to do it, but this one is only for few people who really can memorize formulae. I hardly mark exams and students do it this way. But if you do it, congratulations. You write this formula down. You match them. X squared, y squared, plus plus. 2f has to be equals to 6k. 2f has to be equals to 6k because you're matching them. So what will f be? You divide by 2, divide by 2. F is 3k. Now, for the next one, 2g has to be equals to minus 2k. You divide by 2 on both sides, so g equals to minus k. And c obviously is equals to 7 there. And the zeros are the same there. So now, the center is minus f minus g. You have to have memorized this. Minus f minus g, that will give you minus 3k, because f is 3k, so minus f is minus 3k. G is k, minus k is minus k is plus k. So that's your answer for the center. To get the radius, you have to have memorized that. F squared plus g squared minus c squared. F squared is 3k squared minus g is minus k squared. The g comes from up there, the f comes from up there, and the c comes from up there. You put that and you get that for the radius. Good luck if you can memorize that. The very few students who memorize this 1, 2, 3 formula. For part C, they said the line with that equation, y equals to 2x minus 1, intersects C. So we have a line and a circle. A line is a straight line, and a circle, they intersect. So if I were to put, so that's the circle there, and that's the line, and they intersect, the meet. What intersect means is where they meet. So the coordinate there will be xy. The coordinate will be xy. And that's your y-axis, and that's your x-axis. So they want to find where they meet. That's the plan. So to solve this equation, we will take whatever we have for y and replace y in the equation for the circle. So the y there, replace the y in the circle equation, and it's going to be long, and you have to be careful when you simplify it. So we'll have the x squared the same, the plus the same, the 6kx the same, this plus the same. Instead of y, we put 2x minus 1 squared, the minus the same, the 2k the same. Instead of y, we put 2x minus 1, the plus the same, the 7 the same, and then the 0. Now is to solve it now. With careful and detail, write your work neatly, because in an exam, you will probably be nervous and rushing. This is question 10 or so. You'll probably be nervous and tired, so be very careful you don't make any mistake. So I write things out neatly and wide so I can see them clearly. So I'll put the x squared together. So x squared, 1x squared plus 4x squared gives me 5x squared. I do the kx, the 6k minus 4k x, it gives me 2kx. And then 1 plus 7, it gives me the 8. And then I have the plus 2k. Now, I will factorize the ones with x. This one has x, this one has x. So x can come out of the bracket. You're left with 2k minus 4. So using b squared minus 4ac is bigger than 0. A is 5, b is this expression there, 2k minus 1, and c is that expression there, 2k plus 8. And then from there now, you have b squared minus 4ac. That's A, that's C. Expand the double brackets, put them together, and you get that expression there, that inequality. So with that inequality, you put it in your calculator, it gives you the two answers, 1, 2. So you can see there, I put in the calculator, ax squared plus bx, it gives me the two answer. And then you can also check what 7 plus square root of 85 is 16.21, which is there. This is 7 minus 8 minus 2.21 in decimals. And the reason why I said you can check with it is because those who have this graphics calculator, you can know the answer before you start the question. If you do the graph, you put that graph in your calculator, you get that graph, you will get that answer 16.21, which is there. And it is the same as the 7 plus root 85. So we want your answer to be A is less than this number, because on this side, that's the side where you get the answers is bigger than 0. If you see here, the graph is bigger than 0 from this number going that way. From here is bigger than 0. So you want K to be a number less than that, or K should be a number bigger than that. So question number 11. They've given you the equation V equals to A, B to the T. To change it to log and to linear form, we have to put log in front of the V and log in front of the A, B, T. But what do we do when you have two things that you multiply? With one of the laws of log, you separate them by adding. And what do you do when you have something to the power? You bring it to the front. So we have log V equals to log A plus T log B. We can swap their position, bring this log B there, and the T goes to the front, and then the log A goes the other way. Because 2 plus 3 is the same as 3 plus 2. So I've just swapped their positions so that I can compare it with y equals to mx plus c. So now we got it in the form which is a straight line. So we know x1 is 0, y1 3. So we use that formula for finding the gradient. So it's 2.79 minus 3 over 10 minus 0. That gives us a gradient of minus 0.021. And c is 3, because we have x is 0 and c is 3. The y-intercept is 3. So your equation is y equals to minus 0.021 x plus 3. Now, when t is 0, you will put y equals to, substitute 0 there, y will be 3. Now, log this was on the y-axis. So log v to the base 10 equals to 3. So this 10 is looking at that 3. So 10 to the power 3 is 1,000. Part B, we know v equals to a to the bt. When t is 0, you put 0 there. V equals to a times b to the 0, which is equals to a. And we got this expression from before. Log of b to the base 10 is equals to m. M stands for gradient. So 10 to the power m, and m is minus 0.021. So 10 to that power, it gives you b to be 0.953. So you know A is 1,000, B is 0.953, and C. So that's your formula there. Exactly 2 years after it was bought, the phone was 320 pounds. So you buy a phone for 1,000 pounds. After 2 years, the price is 320 pounds. Does that make sense? Is that fair? But we use the calculation to see if this model works. 2 years is 24 months. because it's 12 months a year. 12 times 2, it gives you 24 months. So in that formula, we put 24 months. Put it in the calculator, it gives us £314.94, which is not far from 320. It's not much difference, just £6 difference, £6 or so. It's £5 actually, and 6 pence difference. So the difference is small. So this formula is what we say is reliable. Reliable means the difference is very small for the estimated and the real value. Question number 12, 5 marks. Question 12 is a differentiation. It's a differentiation from first principle. So the first thing is you have to get this formula from the formula book. This formula I put there in that box. You have to get that from the formula book. And the L stands for the limit as h tends to 0, as h becomes a very small number. So instead of x, you put sine x plus h minus sine x. Minus f of x is our sine x. So in that formula, you put sine f of x plus h. That means you replace x with x plus h, and then put the sine x divided by h. Now, what do we do with sine x plus h? That's the problem. You go into that compound angle formula and expand it. So it becomes sine x cos h plus cos x. So that in the circle there is this one which you expand. Minus sine x over h. Now, you want to start to simplify it and rearrange it. So you want to use this one that says, you see the sine x minus sine x, and then the sine x cos h. So that the sine x will come out of the bracket, and then you have cos x minus 1 all over h. And then you will use this one, sine h over h, this one, times cos x. And then you use the idea that cos h minus 1 over h tends to 0, and sine h, that tends to 1. So this one tends to 0, and this one tends to 1. 0 times sine x is 0, so all of this will be 0. This one will tend to 1. 1 times cos x just gives you cos x. So your answer will be 0 times sine x plus 1 times cos x, which gives you cos x. Hence, the derivative of sine x is cos x. This is what you have assumed. As you may assume, this is given for you to use that. Question number 13. So it says, find a complete equation for the model. So we've got the equation there. What do we need to find? We need to find what A is, and we need to find what B is. We need to find what A, and we need to find what B is. So when time is 0, h is 2. So we put time is 0, put h is 2, and we solve it, we'll get 2 is equals to A minus 400B. dh over dt equals to 0 at the maximum. So when you differentiate that, you get 0 minus 2b bracket t minus 20 times 1. And you simplify that, you get that expression there. So it's very important to understand this part. For this thing to be at the maximum, this part where we minus b bracket t minus 20, this one has to be 0. Because whatever we have for A is 60 meters. We don't want to remove anything from the 60 meters. We already have 60 meters. So for it to be a maximum, that means all of this has to be 0. And for it to be 0, we can solve it to see when this is 0. So we make that equals to 0. So h has to be equals to A to get the maximum. So that's the plan behind it. So we have 2 meters is equals to 60 minus b bracket t minus 20 squared. and put t is 0. So 2 is 60 minus b times that. And we would have, when you solve that, you get b to be 0.145. So A is 60 and B is 0.145. So that's the complete equation for that. Part B, use the model to determine the height of the carriage above the ground when t is 40. You put the time is 40. Some people say 4e. You put 4e in there and you put that in your calculator. It gives you 42 meters. And it's 40 seconds to go around. Part C, they've given us another equation and they want us to find a complete equation. That means we need to find what alpha is. We need to find what beta is. So we need to find alpha and beta. So we now have to differentiate dh over dt. When you differentiate the inside function first. When you differentiate 9t, you get 9. You differentiate alpha, you get 0. And we have that 29 there. We differentiate the cosine, it becomes sine minus sine when you differentiate cosine. And you have the 9t plus alpha. And when you differentiate beta, you get 0. So we want to solve dh over dt equals to 0. So 9 times 29, it gives you 261. Put all of that equal to 0. Divide by 261. So we solve this equation, inverse sine of 0. And so alpha will be equals to minus 90. So now we want to replace this alpha with minus 90 so that we will have h is 60, replace alpha with minus 90. 90 minus 90 is 0. So cosine of 0 is 1. So 60 is 29 equals to 29 plus b. So what b is, not b, beta. Beta is 31. When t is 0, h is 2. So we put h is 2, put t is 0. And we know what beta is, and we can solve it. Substitute for beta, which is 31, and solve the equation. Take 31 to the left. 2 minus 31 minus 29. Minus 29 divided by 29 minus 1. Inverse cosine of minus 1 is 180 degrees. So we have alpha will be 180 degrees, beta would be 31. And that would be the equation. So the carriage moves continuously for 2 minutes. 2 minutes is 120 seconds. So instead of time, we replace it with 120 seconds and work it out. So h, you work what that would be. So when we do that, this one will give us a height of minus 1,390 meters, which is not good. 1,390 meters. If you look at that, that one is not good. And this one will give us 2. So if you look at the two answers, one of them, when you put 120, that's 2 minutes, we get 2. When you put 120 for this one, 2 minutes, you get minus 1,390. So that's it, where you substitute the 120 and the 120. Two different answers. Question number 14. Prove using algebra that n plus 1 cube minus n cube is odd for all n an element of natural numbers. So let's expand n plus 1 cube using the binomial expansion. So when you use the binomial expansion, you'll get that expression. And the n cube minus n cube would be 0. And you end up with this quadratic. This quadratic is what we want to prove that is odd. So we can factorize 3n out of, use this 2 and factorize 3n out. So 3n will come out, you're left with n plus 1, because 3n is the same as 3n times 1. So factorize that. Now, this is where you need to know some of these facts. And I'll show you quickly before we start talking about it. Let's start. An even number times an even number, it gives you an even number. An even number times an odd number, it gives you an even number. That's the important one here. Even times odd, it gives you an even number. Or odd times even would be the same. So it's very important. This is the one we're going to be using that. And these are other things for you to learn on the side. And the next thing is, if you multiply an even number by 3, the result will be an even number. Take, for example, the even number is 2. You multiply by 3, you get 6. If the even number is 4, you multiply by 3, you get 12. If the even number is 10, you multiply by 3, you get 30. So let's start with an odd number for n. Let n be odd. So this n is odd. And then in the bracket, an odd number plus 1 will give you an even number. Odd number plus 1 will give you an even number. Now, when we multiply odd number times even number, what do we get? We get an even number. But when we multiply 3 times an even number, we get an even number. And when we add 1 to an even number, we get an odd number. The same here. If we choose n to be an even number, in the bracket, you add an even number plus 1, it gives you an odd number. An even number times an odd number, it gives you an even number. 3 times an even number, it gives you an even number. Add 1 to the even number, you'll get an odd number. So that's the complete picture of question 14. Question number 15. Question 15. It's not difficult, but it's quite long, and there's a lot of algebra in terms of simplifying and rearranging. So it's not a very difficult question, it's just that it is long. And by this time in an exam, you're tired towards the end of the exam. So I'm not surprised why lots of students did not finish this question or got stuck with it. But if you start it as your first question, you probably do it in an exam. We have two things there. We have a numerator and we have a denominator. So we're going to find that it's best to put the numerator, make it equals to u, and differentiate it. Differentiate 7x e to the x. We will have e to the x times 7 plus 7x e to the x. I'm using product rule there to differentiate it. And then if I put v to be the denominator, instead of the square root, I put the power half. To differentiate this, dv over dx, we'll multiply by the power, which is a half. Subtract 1 from the power, half minus 1 gives you minus a half. And then we differentiate what is inside and multiply it. Differentiate e to the 3x, it gives you 3e to the 3x. Differentiate minus 2, you get 0. So that's what you get when you differentiate it. And I'm going to use a quotient rule formula, which is written there. So we put all of that together in the quotient rule formula. We want to put v first, and then we put du over dx, which is the one in pink. And then after that, we put u, which is a 7x e to the x, and then minus the du dv over dx, all over v squared. So I replace the v, replace the du over dx, replace the v, replace du over dx, and then there's the minus there, replace the u, and then replace the dv by dx, and then replace the v there. Now let's deal with the numerator first. And before we do that, let me write it neatly for you. Use that numerator y equals to 7x times e to the x. So there's a times in the middle there. We don't usually write the times. So 7x times e to the x. So we're using product rule. And that's the product rule there, the formula for product rule. So u is x, 7x, and then du over dx is 7. V is e to the x, dv over dx is e to the x. It doesn't change. Substitute them in this formula for product rule. V e to the x, du over dx, which is 7. The plus stays the same. The u is 7x. The dv over dx is e to the x. Factorize, 7 is common. 7 is common. E to the x, e to the x. So here it's like times 1. So the 1 will remain there. And this will be x. We factorize. So it's 7e to the x bracket x plus 1. I just swapped the position for the x and the 1. 1 plus x is the same as x plus 1. So this is how you write it neatly in an exam. Now, we move to the next part. So we had our numerator 7x e to the x, which was our u. And we know when we differentiate it, we get this 7e to the x bracket x plus 1. The reason why we factorize it like this is because the answer needs us to do it that way. So we need to arrange it to get to that answer. Now let's do the denominator. It's a different e to the power 3x minus 2 to the power half. We want to find dv over dx. So we put half in front. Minus 1, half minus 1 gives you minus a half. Differentiate e to the 3x, you get 3e to the 3x. Differentiate the 3x, you get 3. And that's the 3 goes there. And then e to x, 3x stays the same. Differentiate minus 2, you get 0. Put it together. Because minus a half, it comes to the denominator, it becomes to the power plus half. So it's 3e to the 3x divided by 2 e to the 3x minus 2 to the power half. Put them together in that quotient rule formula. Now, this is all 4 of them. 1, 2, 3, 4. The big 4. You can see why I said this question was all very long in terms of all this simplification. But you put those 4 things in this formula, you get that the v there, the du over dx, the minus there, the u there, the dv over dx, and then the v squared underneath. Now, how do you simplify all of this? And one thing you must know is that half times 2 will give you 1. So that's why e to the 3x minus 2 is there. So what we're going to do, we're going to multiply each term by 2 e to the 3x minus 2 to the power half. So we'll multiply the first one with that expression in green. Multiply the second one with that expression in green. Multiply the denominator with that expression in green. And you might say, why did we choose that expression in green? That expression in green comes from this denominator here. They're the same. And the reason is we want to get rid of that fraction. So it's like saying 3 over 8. You multiply everything by 8 so that the 8 will cancel. And you get rid of the fraction. Now, let's simplify it now. So you would end up with 7 times 2, it gives you 14. And then you end up with that expression there. And then there will be 7 times 3, it gives you that 21. And then you add, this is 1 plus half. 1 plus half is 1 1/2, 3 over 2. So that power 3 over 2 there. That's how I got the 3 over 2. And then from there now, we can go ahead now and do some factorization. Watch this carefully. 14 is the same as 7 times 2. And 21 is 7 times 3. So we will take 7 out, and then we'll be left with 2 inside. And then we will take 3 out. 7 times 3 is 21. 7 times 2 is 14. So that shows you why we factorize, and they'll put that square bracket. And then this one stays the same. This will be 3x. And then what we do now is, because we had to multiply by e to the x, So that would become e to the 4x, because e to the x, ex to times to the power 4 e to the 4x. So we put together the like terms, we'll get this expression underneath. And then when we start to factorize and rearrange, you would end up with minus 4x minus 4. And then you factorize e to the 3x and then 2 minus x, which gives us the 7e to the x, the e to the 3x, the 2 minus x, minus 4 and that. So a is minus 4, b is minus 4. Part B, hence show that the x-coordinate of turning points. So when you see turning point, you want to find dy over dx. So you want to differentiate that expression there. So dy over dx equals to 0 at the turning point. But since this is already the dy over dx, we put it equals to 0 to solve it. So you cross multiply, and you end up with this expression equals to 0. So either 7e to the x equals to 0, or this expression equals to 0. So what you can do is you can remove the brackets. So it becomes 2e to the 3x minus x e to the 3x. And then we start to rearrange it. We'll take the x e to the 3x to the right and the minus 4x to the right. And then we factorize x out. So it becomes x times e to the 3x plus 4, which you take to this side and divide, and that gives you what x is. It shows that expression there. They say use the iteration formula. Find the value of x2 and the value of beta. So if we have n is 1, 1 plus 1 would be 2. So we put 1 there. 1 plus 1 is 2. And we put 1 there. And we put 1 there. 2e to the 3 times x1. So since we know x1 is 1, we put 1 there, put 1 there. And then start to simplify that. So in the calculator, we'll get 1.50177561. So the clever thing in the calculator is you would use this answer, put it the same formula again, but instead of 3 times a number, instead of you typing this long number, you just put 3 times answer over the bottom there, 3 times answer. Sorry, 3 times that answer, and you put execute, it gives you the next answer. And you will use that next answer in the formula again. It will give you the next answer. And you will use that process, repeating the process to get more and more answers. When you get 1.966, you put that in the calculator for that answers, you get 1.967. And when you do it again, you get the next answer. You carry on until you get 1.967. 1.967, the first 5, 1.96756, 1.96756, these are the same. So you can stop there because you got enough answers to 3 or 4 days. For 15C, this is y equals to x, that straight line there going. So what you want to do is you start at 1, you go up to the graph, you reflect it to the y equals to x line. That gives you the value x2 down there, 1.502. And you go back up to the graph, reflect it, you come down, it gives you the beta of 1.967. So beta is 1.967. So beta is 1.968 to 3 decimal places. So for part E, using a suitable interval and a suitable function, that should be stated, show that alpha is equal to 0.432 to 3 decimal place.